Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, let's take the another problem on circular arch. Let's see in details. Now see, this is a question given to you. A semicircular symmetrical 3-inch arch has a span of 20 meter. The arch sustains a load of 45 kilonewton per meter on the left half of the span. Determine the horizontal thrust, means we have to find the reaction and horizontal thrust, the moment, radial shear and normal thrust at a section 6 meter from the left hand support. Now here you have to find the moment also, radial shear and normal thrust at section 6 meter from the left hand support, means you have to find the maximum positive or maximum negative also over here, because we have to draw the diagram also. That's why we have to find mx and maximum and minimum also. Okay, so draw bending moment diagram. Now in that, not given the diagram in the exam, so please write it the diagram first. Now see, this is a semicircular, as you all know, this is a semicircular symmetrical 3-inch arch, has a span of 20 meter. So the span will be 20 meter over here. This is your arch. Span will be 20 meter. Span will be 20 meter. The arch sustains a load of 45 kilonewton on the left half of the span. The arch is sustained. See, the arch is sustains a load of 45 kilonewton per meter, means it is nothing but it's a UDL, because unit will be kilonewton per meter on the left half of the span. Means on the left half of the span, the UDL will be 45. Okay, kilonewton meter. Now after that, now see, on the left half of the span, determine the horizontal thrust. Now you have to find these things, and here there is one unknown over here. Can you hear that? See, here is not given the h value over in this. We don't give in the question the h value. Now how will you find this h? What's the distance will h? So take one note that you can better understand how to write when h is not given. Note, since the arch is symmetrical, that's why h is equal to 10 meter in circular. Means in circular arch, if h is not given, so take the half of the length, means this is 20, so this will nothing but 10. Okay, always keep remember those things over here. Now after that, we have to find first reaction over here. So how will you find the reaction? See, this is your A. C. Now find the reaction. This is HA, HB, VB, VA. Okay. Now see friends, our first step is nothing but find horizontal thrust. While finding horizontal, first we have to find the reaction. So let's start with the solution now. Now our first step will be reaction and horizontal thrust. Okay, reaction and horizontal thrust. Okay, now how will you find the reaction? Since this is symmetrical arch, as you all knows, first we have to find the moment, then y, then x. So summation moment at a equal to 0, clockwise positive. Now see, what is given, come over here. When we are taking moment at A, this UDL is coming in the picture and this VB only. Okay, so this will go in, see, from applying load from upward, this will go in this direction, so this is moving in this direction, so this is clockwise. So 45 into 10 into 45 into 10, this is nothing but 10 meter, this is also 10 meter. 45 into 10 into 10 by 2, as you all know how to convert UDL into point load. Okay, so first value will become over here 45 into 10 into 10 divided by 2. After that says this VB is only there, so VB into this distance is nothing but 20, because we are finding moment over here. So VB into 20 minus VB into 20 equal to 0. Okay, equal to 0. Now you are finding this, you got the value of VB will be nothing but 112.5 kilonewton. Okay, after that we are applying summation Fy equal to 0 upward positive. Write the reaction over here, 112.5. Okay, now when we're finding why this VA is coming, this 45 into 20 is 10 is coming, only take the load, not take the distance. So 45 into 10, then minus 112, sorry, plus 112.5. So will come like this, VA minus 45 into 10 plus 112.5 equal to 0. While solving this, you get the value of VA will be 337.5 kilonewton. Okay, 337.5 kilonewton. Okay, now after that we have to find the horizontal thrust. So we can write over here, since C is an internal hinge, since C is an internal hinge, consider part CB to find H. See, if this is a question given to find H, you can either take CA or CB. We are taking CB because it's not complicated. When we take CA, we have this come in the picture UDL also. That's why it will be quite complicated for us. So we can take the where they have no load. So we can take BC. You can take from both the side. Get the answer will get the same. Okay. So we are taking C and B. Now what you have to do, what is the sign convention you have to follow? The sign convention, as you all knows, sagging positive, hogging negative. Okay, this is a sign convention. Now let's start with the now see, when we are taking bending moment over here and seeing this side, see this will go in this direction. So this is nothing but positive 112.5 into this distance is 10. So bending moment at C equal to 0, 112.5 into 10, then minus, see this H. Now see friends, now we have this bending moment at C means this 112.5 into 10, then minus this H will become C, because this is nothing but in this direction we are taking section over here and we are taking this will go in this direction. So this force into that perpendicular distance will be 10. So HB into 10. HB into 10, okay, equal to 0. While solving this, you get the value of HB will be 112.5 kilonewton. Okay, as you all knows, both the H are same, so HA is equal to HB equal to 112.5 kilonewton. Now we got the value of horizontal thrust also. Okay, now after that put it in this. Okay, now after that next question will be asked over here is the moment, radial shear and normal thrust at a section 6 meter from the left hand support. Now you have to find the bending moment Now find next one will be bending moment, radial shear and normal thrust. Now we are finding bending moment, radial shear and normal thrust over here. Okay, so what we are considering first, see, when we have to find the moments at certain distance, what we are doing over here, see, in this question we have asked also to draw the bending moment diagram. So we have to say that at 6 kilometer we know the distance of x as 6 kilometer. First time take this section, this time take CB section, we got the value of maximum positive and maximum negative bending moment. But here we have given the question, take the section at 6 meter from A. So we have to take the section in 6 meter from A. Okay, so in circular arches you have always given the distance, one distance is always given to you. Okay, so what you have to do first consider part AC. First consider sign conversion is sagging positive or hogging negative, vice versa. Okay, now first what we are taking, first we are taking AC part. So draw the FBD of that AC part. So this is the FBD of AC part like this. Okay, and we have to find bending moment at 6 meter from A, means 6 where something here is coming, 6 is coming here, 6 meter. So if this is 6 meter, so what is this distance? This distance is nothing but our, as you all know, x is equal to 4 meter. It is a circular arch. In circular arch the origin is in the center. So please listen the carefully first and then solve. And this distance is nothing but y. Okay, and this distance, you know, the intensity will be 45 kilonewton per meter. Okay, now after that what we have to do, now we have to write the bending moment at D, this name as D. Now we have to take this section and see this side, and we have to find the moment over bending moment over here. So what will come over here? 337.5 into 6, then minus 112.5 into y. 337.5 into 6, then minus h into y. As you all know, 337.5 into 6 minus 112.5 into y. And this UDL is also come in the picture. See, here we had forget to write the UDL intensity. This will come minus 45 into 6 into 6 by 2. Here also write. Take it as equation number 1. But as you all knows, but y is equal nothing but r square minus x square minus r plus h. Considering C as origin, now considering this C part is origin, the C part is origin, so we have the formula of r will be L square upon 8h plus h by 2. Now put the value over here. L, where is the total L will be 20 square upon 8 into 10 plus 10 by 2. We got over here is equal to, we got the value of r will be 10. Okay, r will be come over here 10. This will coming at 10. R will be coming 10. Now y is equal to under root 10 square minus, as you all knows, here we have given the x value. X is nothing but 4 meter because we know this distance, minus 4 square minus 10 plus 10. So this 10 will get cancelled. Directly you got the value of y will be 9.16 meter. Now this y value put in equation 1. Put in equation number 1. Now equation number 1 will be this. So put in equation number 1, what value will come? 337.5 into 6. Bending moment at D will be 337.5 into 6, then minus 112.5 into 9.16 minus 45 into 10 into 10 by 2. Now while solving this, you get the value of bending moment at D will be 184.5 kilonewton meter. It's nothing but sagging. Now see, this will come our maximum positive bending moment also over here. After that, let's consider the other part. This is nothing but C and B. Okay. Now see students, we have done with this part A and C. We have done with this part and we got the value of sagging 184.5 into kilonewton meter. Okay. Now after that, this is nothing but 4. After that, let's read the another part, just nothing but C and B. So consider portion. Take new page to solve this. Consider now consider portion BC. Draw the FBD of BC part over here. What will it will be look like this? This is your VC. We know this value 112.5. We know this value 112.5. Now okay. Now what we have to done over here? Here we don't know anything now. We don't know the x distance as well as not know the y distance. So take randomly one section over here, and this distance is nothing but your. Now here this is your x distance, but this distance is nothing but 10 minus x. As you all knows, arch will say this is your x and this is your y. Circular arch says this. So this is your x. So this will be nothing but 10 minus x. Because when we are taking section over at E, taking name is at E. So at that time we want this distance. We don't need this distance while solving the bending moment over here. So that's why we do to write this also. This value will come 10 minus x. Okay. Now let's start with the. Now as you all know, the sign convention is like this. Positive. Sorry. Negative. Okay. Now let's start with the. Now see, we have to write bending moment at E is equal to. Now see, this is 112.5 into 10 minus x. 112.5 into 10 minus x minus 112.5 into y. Okay. Name it as equation number 1. But you know the value of y, as y will be under root 10 square minus x square minus 10 plus 10. R will be, you are calculating previous one only, that this 10 will get cancelled over here, and put this value in over here, this y. So you get the value 112.5 into 10 minus x minus 112.5 into under root 10 square minus x square. Okay, 10 square minus x square. After that, what you have to do is, as you all knows, if you don't have the given distance x to find distance, as you all knows, to bending moment E will be to be maximum. Sorry, bending moment at E to be maximum, d by dx of mx is equal to 0. Sorry, me, not x, it's E. Okay. Now E. Now say take the derivative of this. This is nothing but just into the bracket first. Just into the bracket. So this value will come. I will come write it over here only 112.5 1125 minus 112.5x, then minus 112.5 into 10 square minus x square. Just forget to write this line, that's why it's very complicated to see, but please see this. Just into bracket, just open the bracket over here. So now we have to take the derivative of this. Now we have to take the derivative of this will come 0, minus 112.5, then minus 112.5 into 1 upon 2 under root 10 square minus x square, then minus 2x is equal to 0. While solving this, you get the value of x will be 7.07 meter from C. Now we got the value of x is equal to 7.7 meter from C. We have got the value from C. Now we want distance, this distance, so 10 minus x. So put in equation number, put x is equal to 7.07 in equation number 1. So we get the value over here, 112.5 into 10 minus x minus 112.5 into under root 10 square minus x square. Okay, so put the value of 112.5 into 10 minus 7.07 minus 112.5 into 10 square minus 7.07 the whole square. Okay, so here we got the value of 465.99 kilonewton meter is nothing but hogging. Hogging means bending moment at E will be 446.5. Hogging means is nothing but negative bending moment over here. Okay, now we have done with the second part also. Now third part will is nothing but your radial shear and normal thrust. So we find the normal thrust and radial shear. Normal thrust and radial shear. Normal thrust and radial shear. Okay, in that directly you can use the formula, because I have explained you 2 to 3 times logic. So either you can, here I am using the formula, or you can use the logic also. Okay, now students, we have to start with the normal thrust and radial shear force. Here I am using direct formula because in previous 2 sums I have explained you the logic also. Here I am using the direct formula. Is normal thrust formula will be h cos theta plus v sin theta. Leave 1 to 3 lines. After that write f radial shear force v cos theta minus sorry, not tan is not possible, sin theta. Okay, after that now we have to find the what is v and what is h over here. Okay, what is v and what is h over here? See, as we have to find the normal thrust and radial shear force at this part A and C, that's why at 6 meter, suppose 6 meter is over here, so we got this VA value will be 337.5 minus 45 into 6. This is your V value. So your V value will be 337.5 minus 45 into 6. This will come 67.5 kilonewton. This is your V value. On H is nothing but 112.5 kilonewton. This is your V and this is your H over here. Okay, so please remember this V. How it's V coming? See, we are taking at 6 meter, you are finding normal thrust and radial shear force. That's why this is positive and this UDL also come in the picture. To balance this UDL, you should give the minus. Okay, so 337.5 minus 45 into 6. This will come 67.5 kilonewton and 112.5 kilonewton in H, because in H there is only horizontal force is only H. That's why to oppose this only H will come. This is your H. Now how to find theta over in circular RC? As you all know, tan theta is equal to dy by dx. Okay, now here dy means plus x upon y we have to put over here. 4 upon 9.2, this is equal to 0.438. Therefore tan inverse of 0.438, okay, so the theta will be 23.65 degree over here. Okay, so please listen. In circular arch you have to find upon x upon y to find the theta. Always remember these things. Now put over here and we got the value of nt will be 130 kilonewton and f will be 116.8 kilonewton. Now put the value over here. V will be 67.5 cos 23.65 minus 112.5 sin 23.65. okay, here also h will be 112.5 cos 23.65 plus 67.5 sin 23.65. okay, now here we are done with this normal thrust and radial shear force also. After that we have asked in the exam is draw the bending moment diagram. As you all know, to draw the bending moment diagram it's very simple. Bending moment diagram. Now bending moment diagram is very simple, as I'm explaining you always as we are solving arch. So first draw the one arch like this. First draw one arch and this is your B part, this is C part and this is your A part. Now see, in A to C we have a UDL, so our maximum positive, so it will look like come like this. On here it is negative, so this will come like this. Now see, this is your positive and this is your negative. Okay, now see, here we find it which meter, 6 meter, a maximum positive bending moment. Here distance will be 7.07 meter. Total span will be 20 meter over here. Write the value also of this. This will come, it's nothing but parabolic arch. Write the value of over here minus sign and here plus sign. This will come 465.99 or this value will be 184.5. okay, unit will be kilonewton meter. Okay, kilonewton meter. Now see, now we have done with this problem of the circular arches. In circular arches we have done with this two types of problem over here also. Now we have done with this supported at same level, supported at different level and supported circular arch. But in exam mostly is asking supported at same level or different level. It's rare time, it's 10% chance to ask in the exam the circular arches. But I have explained you two questions for your better futures. You can read it and go to the exam. I hope you understand my videos. Don't forget to subscribe the Ekeeda channel and share with your friends. Thank you so much.